All right, so this video we're going to be talking about what was shown in a video. If you look up how many ways can you arrange a deck of cards, there's a TED video that represents it. And what we find is that it takes a bigger number than any of us could ever possibly say of how many combinations of cards there are. And so how we get that is through a series of problems or a rule in math called permutations and combination. So we're going to talk about what those mean and how we find those. Really what it means is how many ways can I arrange something. And so we have some notation that we're going to use. Some ways of writing things that we are going to use that it's going to be helpful for us to know what each piece means. So the first thing, both combinations and permutations, or these things that we're going to talk about, use these symbols to solve. The first one is an exclamation point, and it's called a factorial. And what it means is we multiply every number from the given number to 1. So if I'm taking 4 factorial, my given number is 4, and I multiply every number that's smaller than that but until I get to 1. So 4 times 3 times 2 times 1. Okay, and when I type that in my calculator, I find that I get 24. So if I take the factorial, or looking at every option less than, we get 24. And what that's referring to is if I have 4 types of ice cream, I could arrange them by putting all 4 of them in an order, A, B, C, D. Then the next time I do it, I could keep A in the same spot, but this time I'm going to change the other letters around, okay? And what's changing is these 3 that are changing. And then I can do it again, and I have 2 that are changing, C and B. These 2 changed. And then lastly, I can do it again and keep those other pieces the same, but the only thing that's going to change is the one last piece, okay? All of this to say we're looking at how do things change over time. In our calculator, what you're going to do is you're going to type the number, and then you're going to click a button that says PRB. That stands for probability. You're going to select the exclamation point, and then you're going to hit enter, and it will solve this for you instead of you having to type out the whole thing. So that's a factorial, and we'll see those show up in just a minute. Next is n, and n is the number of possible things to choose. So if you're at an ice cream shop, it's all the different flavors. If you're making a pizza, it's all those different toppings. If it's the jobs that you could be applying for, it's all the different jobs. So in our example, there are 6 people and 4 chairs for them to sit in. 6 is our n value because that is the number we are choosing from. That is the people that are going into those spots. Okay. And lastly, we have R. R is the number of possible positions for our choices. What are we trying to fit our choices into? And so in our example, there are 6 people and 4 chairs for them to sit in. It's the 4 chairs are the options available. Okay? That's where they're going to sit. That's where we need to fit the 6 people in and what we're trying to find those combinations for. So we'll do an example that uses this. When we have situations where we are just thinking of how many things put together, that is called a combination. And a combination is where order does not matter. So this is like toppings on a pizza or ice cream. right? It doesn't matter whether you put the strawberries on first or the sprinkles on first. They're all going in the same place. It could be something like selecting a team, selecting students for a class. There's no first place in a class. It's just you're in the class or you're not, okay? The equation that we have is n factorial over r factorial times n minus r factorial. So what that gives us is it gives us the number of possible combinations for the situation. So when I have, in my example, there are 6 people and 4 chairs for them to sit in, we would say we have 6 choose 4, or 6 things and we're choosing 4. And I'm going to plug those values into my equation. So I have 6C4 is equal to 6 factorial over 4 factorial times n minus 6 minus 4 factorial. In my calculator, I find that 6 factorial is 720, 4 factorial is 24, 6 minus 4 is 2. So I'm just simplifying those values by using my calculator. So I get 720 over 24 times 2 times 1, which is 2. So I have 720 over 48, which is equal to 15. So there are 15 possibilities, possible arrangements. I shouldn't say arrangements, possible combinations. 15 possible combinations. Okay. In situations where the order does matter, those are called permutations. So permutations are where the order does matter. This is where I'm going to pause and say, if you are listening to this video, please write the word pink on a piece of paper and turn it in, and you will get a prize for listening. But permutations are where the order does matter. And so when the order matters, those are things like first, second, third place in a race. It's like saying scoops on an ice cream cone. Right? There's a bottom, a top, a middle. It's like saying any kind of thing where the position matters, okay? The order or the position matters, okay? Our equation is very similar. The only difference is that we do not have that r factorial on the outside. So because I don't have a piece on the denominator of my fraction, my p or permutation is always going to be bigger than a combination. And we can think about this, right? If you just care about who's in the top 3 of a race, but you don't care what order it is, it's just going to be those 3. But once you care about the order, then there's this additional component of how they're arranged that's going to change their probability. Okay? So in this situation, there are 6 people and 4 chairs, each at different spots at the table. So this is saying that the order matters. Well, I'm going to put 6, pick 4. So same positions. Okay, this is my n value, and this is my r value. They do the same thing, but we're going to put them in a different equation. So I have 6 factorial over 6 minus 4 factorial. Well, that's the same as 720 over 2, which is equal to 360. 360 options. Or arrangements, I should say. Arrangements is a little more accurate for the situation. So there are 360 different ways that 6 people can sit in 4 chairs if whether you're sitting at the head of the table or the side of the table matters, if the position matters. So we just plug into our equation and solve. Our key things are determining, is this a permutation or a combination? So does the order or the position matter or not? And what is our n value? What is our r value? What is what we're choosing from? What are the spots that our choices are going into? This first example on your worksheet is a bad example, so we're going to skip it, okay? It was poorly written by me, and so we're going to skip it. What we are going to do is this example here. A group of 25 people are going to run a race, and the top 8 finishers advance to the finals. It just says the top 8. It doesn't say we care about who is in first place or second place or third place or fourth place. We just care that it's the top 8. So, because that order doesn't matter, it is a combination. So the number that we are choosing from is 25 total people, and they are going into 8 different spots. So I have 25 choose 8, which is equal to 25 factorial over 8 factorial, 25 minus 8 factorial. Now, if you do this in your calculator, 25 factorial, you are going to get a massive, massive number. So instead of handwriting it out for these bigger pieces, we are going to use some functions in our calculator. So you are going to type your n value. Then you're going to click on that PRB. Then you're going to type, you're going to select the thing that says combination or NCR. You're going to type your R and you're going to click enter and it will solve it for you. Okay? We can do the same thing with our last problem here. The student body of 10 students wants to elect a president, a vice president, and a secretary. Here we have 1, 2, 3, 4 options, or 4 spots, and the order matters. Where the people are matters. There's a difference between being a president and being a secretary, okay? And so our N is going to be the 10 that we're choosing from. Our R is going to be the 4 spots they can fit into. It is a permutation because the position matters. And so I have 10P4, which is equal to 10 factorial over 10 minus 4, factorial. And then in my calculator, I'm going to follow a very similar set of steps. I'm going to type the N. I'm going to click my probability button. I'm going to select, this time I'm going to select the permutation. I'm going to type my R, and I'm going to click enter, and it will give me my answer. Sometimes you'll have to use the calculator function. Sometimes you'll be able to, or you'll have to write out the steps. It'll depend on the problem. But that is combination and permutation. So we're looking at what those different pieces mean.